Você me avisa, tá?
Ok, já estamos no ar.
Boa tarde a todos. Muito obrigada pela presença de vocês. Boa tarde aos que nos acompanham pelo YouTube. Muito obrigada pela sua audiência. Hoje nós teremos o último seminário da série de 3 seminários do professor Wein, né? Então, esses seminários fazem parte do ciclo de seminários do Departamento de Estatística da UFRN. Então, hoje será o terceiro, the third one, seminário do professor Wein, do Departamento de Estatística da Virginia Tech, no qual ele está falando sobre a regressão Weibull aplicada em confiabilidade. So, thank you so much.
Obrigado, Beth. Oops. Today's the fun lecture. Okay? Everything was just set up for today. I want you to see how crazy life can be. Fair enough? Okay? So I'll go ahead with the first slide, please. Okay, so I'm going to show you the real experiment and the issues that are there. And the issues are serious because they reflect the inability of scientists and engineers to understand proper data analysis, and then the challenges for the data analysis to understand enough of the science and engineering to make progress. And this is a fascinating story. And I'm not telling you the whole story, but enough to see what's going on. So with that, just review, these are things that are going to be important to me. This notion of the survivor function for a while, this is for the classic power law model, which is going to be fundamental for our conversation today, okay? In this residual term, the scale residual term, I'm not going to use them particularly much this today, but I want to make sure we're familiar with the basic survivor function. And the linear model structure that's represented by that relationship. So far, so good? Okay, next slide, please. The notion of a location parameter, again, this is going back to the fact that the classic power law model is just simple linear regression, but it does allow for us to build more complex models. And I'm not quite going to show that today, but the capability is there. So if people want to talk to me outside of the lecture, we can talk a lot about how we can build more interesting models. And it's fun. Now, it is fundamental for our conversation today. Reliability engineers don't understand this relationship. They don't understand this at all. If we go back to the previous slide, can we do that? They think of the classic power law model in that form right there. And it's just Greek, and that's how they think about it. You try to express it, if you take the log of it, they accept that, okay? But for the most part, this is Greek. The moment you start talking about a linear model of this kind of form. Am I communicating? Like we are in different universes, and quite frankly, we all are. So please keep that in mind in this conversation, okay?
Next.
Please. And the next one, please. Now, we're going to do a lot of things visually today. It looks like a pretty simple plot, but it's going to be fundamental to our conversation. That stress rupture model, that classic power law model, I will often call the stress rupture model, because we're looking at stress rupture. We're looking at the probability of failure due to exposure to a constant stress. It assumes that at time 0, it goes immediately to that stress ratio, and then it's on time. So far, so good? It really assumes that. There is no way In God's green earth, you can apply a load in 0 time. However, this model is assuming the load was applied in 0 time. And that's going to be very, very fundamental to our conversation. The reliability engineer plots data along this line, and then he starts looking at the behavior as time goes to 0. Well, all he has is this classic stress rupture model. So far, so good? And if we start thinking about how things happen as I approach 0, that is the context of the community. So far, so good. I'm going to try to defend my friend to the extent that I can. But the problem is, sooner or later, you have to recognize there was some mechanism to get the item to load. Fair enough? Okay. Next slide, please. Here are the actual data, and I have shown it as if it had instantaneous load. Oh, I did something.